Okay, we're going to look at two more examples of integration by parts, and here we're actually going to be looking at a useful technique called the tabular method. And it works out real nicely when you have a polynomial times an exponential or a trig function like a sine or a cosine. And especially when you have to do repeated integration by parts, it can be a little bit tedious, and so this shortens things up a little bit. And so the way it works is you're going to let u be the algebraic part, which is going to be the x cubed, and then differential dv is going to be the rest, which would be e to the x dx, but we're only going to write the e to the x part. Okay, so here's x cubed. And the idea here is we take repeated derivatives until we get to 0, okay? And so we're just doing repeated applications of integration by parts. Okay, so on the u, you just keep taking the derivative. On the dv, you keep integrating. So the integral of e to the x is just e to the x, and we won't worry about the plus c. Okay. All right. And so, here's your u, and here's your v. Okay. So it's going to be uv minus the integral of v du. Okay. So x cubed e to the x, that's your uv. And we say plus. And then it's going to be minus the integral of v du. But instead of doing minus the integral of v du, this is now our u, and this is now our v. Okay, but we got to account for the minus sign in the integration by parts formula, so this will be minus. So minus 3x squared e to the x. Okay, and then we're going to do it again. Here's our u, and here's our v. And if we do another integration by parts, we introduce another minus sign. So this is going to be a minus minus, so this will be a plus. Okay, so 6x e to the x. And then we're going to do the integration by parts again. So here's your u, and here's your v. Okay, and then there's another subtraction that's added in there. So then that makes this one minus. So yeah, minus 6x e to the x. We can factor out e to the x. We got e to the x times x cubed minus 3x squared plus 6x minus 6 plus c. Okay, and so this is just a shortcut. It'll always go plus minus there, and that's because of the minus sign in the integration by parts formula. That's going to cause the alternation. Okay, it is possible that the u's and the dv's will also change signs. It just depends on the functions, but yeah, it would always alternate here, at least in the plus minus. Okay, so that's typically how we'll use it. I will show you another example where the tabular method can be used with something where you don't have one of the functions after you repeated derivatives goes to 0. And so we'll look at a problem that we looked at earlier, and that was the integral of e to the negative 2x cosine of 5x dx, okay? And so that'd be logs, and then inverse trig, and algebraic, and then trig. So trig before the exponential, so and then our dv, so we'll do cosine of 5x. And then we'll take the derivative, so negative 5 sine of 5x, and then negative 25 cosine 5x. Okay, and then if I need more, I'll do more. So then e to the negative 2x, negative 1/2 e to the negative 2x, and then 1/4 e to the negative 2x, okay? And if I need more, I'll put some more in, okay? Alrighty, so we are going to do uv. So uv. Okay. Alright, so uv, and that's going to be positive, but you see that we have the minus sign there, so that's going to actually be a negative. So we're going to have negative 1/2 e to the negative 2x cosine of 5x, and then minus the integral of v du, but then we're going to do integration by parts again, so then we get a u, and we get another v, okay? But we have this minus sign because the integration by parts formula has a minus sign in there, okay? But we have a minus sign also here, so those are going to offset. So we have plus 5 over 4 e to the negative 2x sine of 5x, okay? And then, it's going to be a little bit tricky, but here's your dv, and here's your u, all right? And so it's going to be the minus u, this looks like a u. It's going to be minus your integral of u dv, so here's your dv right here, okay? So we have that minus there. Okay, so we got double negative. So it's going to be 25 over 4 e to the negative 2x cosine of 5x dx. Hold on a second. We made a little bit of a mistake here. This should be actually be a minus here. Okay. So we got minus this and this. So we got 3 negatives there. Okay. So I don't recommend doing it this way with one of these integrals, but it can be used. Okay. So we're going to add the 25 over 4 over, so we got 29 over 4, e to the negative 2x cosine 5x dx. And so that's going to be equal to 1/4 e to the negative 2x times negative cosine 5x plus 5 sine 5x. Okay, and plus constant integration. Multiply both sides by the reciprocal, 4 over 29. And so the integral of e to the negative 2x cosine 5x dx is equal to 1 over 29 e to the negative cosine x times e to negative 2 cosine 5x plus 5 sine 5x plus c. Okay. Alrighty, so that is 2 examples of the tabular method. I'd probably only use it really on the first problem and just do the full integration by parts on this second example. It's easier to follow, in my opinion, easier to grade also in the event that you make a mistake. As I demonstrated, I might have gotten my signs mixed up. So it is a lot easier with this type of problem to just do the full integration by parts, and then I'm able to award partial credit. Okay. Alrighty, so that's it for the integration by parts. Stay tuned for trigonometric integrals and u substitutions. We'll see you next time.